Okay, we're going to look at number 18 on the review sheet. So the first thing we're going to do is we're always going to write our given and our find, because that's going to help us to understand what to do. So it says a 1,383 kilogram car, so I'm just going to call that MA, is moving south at 11.2 meters per second. So that's the velocity of A. Now, I always have to have a sign convention in physics. So first of all, for my direction, I'm going to do north, south, east, and west. And I'm also going to establish my sign convention, and we'll just use the same sign convention that up and to the right is positive like we usually do. So the velocity, if north is up, south would be down. So my velocity is going to be negative 1.2 meters per second. And this is important because velocity is a vector quantity, has both magnitude and direction. Momentum is a vector quantity, and it has both magnitude and direction. So it's moving south. So the first thing I'm going to do is I'm going to draw a picture. So I start right here. They say that this car is moving south, so I'm going to draw it going down like this because south is down. So that's the momentum of car A. It's struck by a 1732 kilogram car, so the mass of B is 1732 kilograms. That's moving east at 31.3 meters per second. So east is to the right, so that's going to be positive. Now they said it's moving east, so when I add my vectors, vectors are added head to tail. So from the head of this vector, I do the tail of the other, and this is PB. So then the question says, how fast and in what direction do they immediately move after the collision? So what I'm finding is V prime, because they're going to stick together. So I have two vectors, head to tail, and I want to find the resultant. This is where I start. This is where I end up. So from where I start to end up, I draw a line. Where I start is always going to be the tail, and where I end up is going to be the head. So this vector here represents P prime. That's the momentum of the two cars moving together after collision. I see this as a right triangle. So to find P prime, all I'm going to use is the Pythagorean theorem. But I need to find PA and PB first. So PA is MAVA, just momentum is mass times velocity. So it's 1383 kilograms times negative 11.2 meters per second. So this comes out to be negative 1.55 times 10 to the 4 kilogram meters per second. And it should be negative because see how it's going down? Then PB is going to be MBVB. So it's equal to 1732 times 31.3 meters per second. So this comes out to be positive 5.42 times 10 to the 4 kilogram meter per second. So now I've found PA, the momentum of car A before collision, PB, the momentum of car B after collision, and now I want to find their total momentum because they're stuck together after. So I'm going to use the Pythagorean theorem, and I'm going to say that P prime is equal to the square root of PA squared plus PB squared. So now I'll substitute in my values. Negative 1.55 times 10 to the 4 squared plus 5.42 times 10 to the 4 squared. So when I do that, the momentum after the collision of the combined mass is 5.64 times 10 to the 4 kilogram meters per second. But that's not what they asked for in this problem. They asked for the velocity. They didn't ask for the momentum. Okay? But I need to find the momentum to find the velocity. So the first thing I'm going to do is I'm going to say, well, I'm going to go back to my first basic definition. P is equal to mv. So now I'm going to apply that to this situation. So P prime, the momentum after collision, is equal to the mass, which is the combined mass, ma plus mb, times v prime. So I just found the momentum after collision. I know the masses, so I can find v prime. So I'm just going to rearrange the equation to solve for the unknown in terms of the known. So v prime is equal to p prime over ma plus mb. So that's equal to 5.64 times 10 to the 4 divided by the combined mass, which is 1383 plus 1732. So the velocity after the collision comes out to be 18 meters per second. But I'm not done, because velocity is a vector quantity, has both magnitude and direction, and this is not going straight in any straight geographic direction, it's going at an angle. So I need to find the angle. So in order to find the angle, I'm going to use my diagram. So remember, P is equal to mv, so whatever direction the momentum is the direction of the velocity, and vice versa, because mass is scalar. Velocity is a vector quantity, it has both magnitude and direction. Momentum is a vector quantity, it has both magnitude and direction. Okay? So what I'm going to do is I'm going to go back and look at my diagram. I always measure the direction from the tail of the resultant. This is the resultant, this is the tail. So it's easiest to find this angle inside the triangle. I have a right triangle. I know all three sides. Can I find this angle? Absolutely. So what I'll do is I'll say that tan of theta is opposite over adjacent. So that's PB over PA, which is 5.42 times 10 to the 4 divided by PA, which is negative 1.55 times 10 to the 4. And when I do this on my calculator, I want to find the angle theta. I don't want tan of theta. So on my calculator, I'm going to press 5.42 EE4 divided by 1.55 EE4 equals, and now I have to press second tan. So it comes out to be 74 degrees. So now this angle here, the angle that I just found was 74 degrees. That's this angle, but I'm still not done. 74 degrees from where? So now I'm going to go back to my picture. I measured this angle here. So this angle here is west of south. So my final answer would be 18 meters per second at 74 degrees west of south. But remember, if I look at my picture, that's this angle. If I wanted to measure it from here, those are complementary angles, so I could also write 16 degrees south of west, and it means exactly the same thing. So they're both correct. But it's always easier to find the angle inside the triangle, because on your answer sheet in parentheses it says 15.9 degrees south of east, but, well, I wrote the wrong thing. This is east of south. This is south and that's east. I wrote the wrong thing. This is east of south. Sorry about that. And this is south of east. So this should be east of south and south of east. Whoops. It's crooked. And again, when you go back to your picture, remember, this is north and this is east. So when we're measuring this angle, that's north and this is east and this is south. So I started at south and I went east. So that's why this was east of south and then this was south of east.